Colby, math.com.
We're solving problems by finding greatest common factor and least common multiple on this assignment. I'm going to do problem number 1 with you. Use a Venn diagram model to find the least common multiple of 30, 45, and 60, and then use this LCM to order the fractions below from least to greatest. We'll order them using the LCM because that will be also the lowest common denominator for those 3 fractions. So we'll start with factor trees for 30, 45, and 60. 30 is 2 15s. 15 is 3 5s, so 30's prime factorization is 2 times 3 times 5. 45 is 3 15s. I can decompose the composite number 15 into 3 times 5. So 3 times 3 times 5 for 45. 60 is 2 30s. 30 is 2 15s. And 15 is 3 times 5. When I sort those prime factors into a Venn diagram, we'll be able to find the product of the prime factors in the union to find the least common multiple. All 3 of these numbers have a common prime factor of 3. So I'll place that in the intersection of all 3. They also have a common prime factor of 5, so that will also go in the intersection of all 3. There are no other 3's, but there is a common prime factor of 2 for 30 and 60 only. So I'll cross 1, 2 off of the 30 tree and the 60 tree and place it in the intersection of those 2 numbers. Not all 3, but those 2. And then 60 has an additional 2 in the 60 only section, and 45 has a 3 in the 45 only section. This would be the point where you would check your work and cover up circles. If I just focus on the 30 circle, we know that this intersection of 3 times 5 is 15, and 15 times 2 is 30. If I just focus on 45, 15 multiplied by 3 is 45. And outside of the 15 and the 60 circle, I have 2 2's. And 4 15s is in fact 60, so everything looks good. The least common multiple is the product of all these prime factors. I can save myself some trouble by realizing that most of them are in the 60 circle, and then 60 multiplied by everything outside, which is just the 3. 60 multiplied by 3 will give me the least common multiple, which is 180. And so each of these fractions can be represented in equivalent form as 180ths. If you look at the 30 circle and look outside of that circle, there's a 3 and a 2. So 6 30s is 180. So a 30th multiplied by a 6th is 1/180th. But I want all of the 7/30ths, so I want the whole 7/30ths, so I multiply by a whole. This is the multiplicative identity. You can multiply by a form of 1 without changing the value. And so while the numerator and denominator change, the fraction is still equivalent to 7/30ths. So 7 times 6 is 42. Why don't you, during the pause, do something similar for 11/45ths and 13/60ths. Multiply them by the correct version of 1 in order to get a denominator of 180. And you can use the Venn diagram to help with that. And then once you have those equivalent fractions, place them in order from least to greatest back in their original forms, and then come back and hit play and see how you did.
Paused.
If I look at my Venn diagram, the outside of the 45 circle are 2 2's, so 4 45s is 180. 45 times 4 is 180, so I'll multiply by 4 fourths here, giving me 44 180ths, and you see how close these 2 fractions are to each other. There would be no other easy way to compare them. No benchmark fractions would really help in this situation. 60 times 3, this is what we use to find our LCM, so I'll multiply by 3/3 here and I get 39 180ths. So now that they're all 180ths, now that I have like terms, I can see this is the smallest fraction. So if I'm listing them from least to greatest, 13/60ths will be first. 42 180ths is a bit less than 44 180ths, so 7/30ths is next. And 11/45ths is last in our list. The benefit of doing all this work is that the next three problems, if you look carefully, you'll find shortcuts for problems 2, 3, and 4 using the work we've already done. So I'll just leave you with that idea, and thank you for watching the video.